Okay, here I'm continuing problem 5 from homework 2. And in part C, it says to calculate the total amount of data that is sent to the physical layer and to calculate the percentage overhead that represents. And I'm going to show you two ways of doing it. Method number 1 is probably the most straightforward. And what I'm going to do is I'm going to say that the total sent to the phi layer is equal to, well, it's equal to the total payload, the 1.5 million bytes, plus the total amount of overhead for 1057 packets. And remember, this payload came from L4, so when I calculate the overhead of 1057 packets, 1057 packets, I need to include the MAC, the LLC, the SNAP, with its with the frame check sequence, and then also the layer 3 IP header overhead, and that was that 20 bytes there that we had to consider. And so the total amount sent to the physical layer is going to be this data, the payload, plus 1057 packets times the overhead per packet. And the overhead per packet is equal to, well, it's the 22 plus 3, 5, 4, and then 20 bytes for the IP header inside of this payload right here. This picture only shows layer 2 headers. Inside the payload of layer 2 is layer 3, and that includes a header. And then the payload of layer 3 is what layer 4 sent down to it. So the overhead per packet is the 22 plus 3 plus 5 plus 20, and then plus 4 more for the frame check sequence. And this comes out, let's see, 22 plus 8 is 30, 54. This is 54 bytes. And so I can multiply these numbers out. Plus 1057 times 54. And that gives us 1057 times 54 plus 1555032. That gives us 1,612,110 bytes. Okay, so that's one way of calculating. The other way is a little bit more complicated. But basically it says that the total sent to the phi is equal to 1,056 full-size frames plus one smaller frame. Remember, in part A, the number of packets was 1056.4, and so we round that up to 1057 because even that shorter packet that is represented by the 0.4 of a packet has to have all its headers on it. But now I'm going to calculate the size of that little packet. Well, let's do the full-size frame. The size of that frame is equal to, sorry it gets crooked there, the size of the full-size frames have a payload of 1492 bytes at the IP layer. They add 20 bytes to get us up to they have 1472 bytes at the IP size. We add 20 bytes to get 1492, which is the payload of layer 2 in IP packets, and then 5, 3, 22, and 4. So the full-size frame is 1472 plus 20 plus 5 plus 3 plus 22 plus 4. And we have 1056 of them. So 1472 plus 20 plus 5 plus 3 plus 22 plus 4 is equal to 1526 bytes. Okay, now the smaller frame has a well, let's see, I'm going to take the 1555032 and I'm going to take out the 1056 copies of 1472 bytes. I'm going to calculate that down here. I'm going to go 1555032 minus 1056 times 1472. And this is going to give me the amount left over in that last frame. Okay? 555032 minus 1056 times 1472. This is going to give me 600 bytes. And this is equal to the layer 4 payload of the small frame. That is that last frame. So the size of the small frame is, instead of 1472, it's only 600 in that last one, plus 20, plus 5, plus 3, plus 22, plus 4. And this is equal to, let's see, 22 plus 8 is 30, 54, 654 bytes. And so now I'm going to say that the total is sent to the phi layer is 1056 times the 1526 plus 1 times the 654. And if things are working right, 1056 times 1526 is equal to that, plus 654, and we get the same number, 161210 bytes. Okay, so there's two ways of doing it. Method 2 requires that you figure out the size of that last packet, which isn't too bad, taking care of everything. Finally, the percent overhead is equal to percent overhead is equal to the difference 1612110 minus 1555032 all over the 1612110. And I calculated this number earlier, and I get 3.54% overhead. Okay, so that finishes up problem 5, showing a little bit extra there how to calculate the size of that last packet. Hope that helps.